Okay, everyone, thank you for joining us today. We are going to get started. My name is Jeff Reiser with TechStar, and I am the water specialist here with TechStar. And so we're looking forward to talking to you guys today about telemetry solutions in the water wastewater market, as well as industrial water wastewater applications. Before I get started on that today, I'd like to introduce you to who TechStar is and what we do. TechStar is a manufacturer's rep firm that was established in the year 2001. We're based out of the Deer Park area in Houston. We also have a regional facility in Euless, Tulsa, Oklahoma, as well as Corpus Christi, Texas. Our territories consist of Texas, Oklahoma, east side of New Mexico, and the west side of Arkansas, and we're actually establishing a territory in the state of Kansas. We represent a full product line of instrumentation and analytical devices. Starting with Yokogawa, we represent Yokogawa for magnetic flow meters, vortex meters, as well as Coriolis. Their full pressure line, as well as all of their analytical devices. They have a temperature product line, as well as data acquisition and SCADA instrumentation. We have general monitors and MSA for gas detection and flame detection. Michelle Instruments and AII for analytical measurement. More Industries for temperature, signal splitters, isolators, and conditioners. We're going to get into SignalFire here momentarily, but we also represent SKF for vibration and condition monitoring, K-Patents for refractometers, Fluenta for flare gas, Fox Thermal for thermal mass measurement, Grayline for ultrasonic clamp-on, as well as their Doppler products. And finally, we represent Vega for all things level. At TechStar, in our water group, we like to say in the water and wastewater industry, there's 4 to 5 major parts of the process that we hear about the most. So we're going to start off with lift stations and wet wells. In lift stations, level is a huge issue, and so we have a full solution with Vega for level, as well as Vega and More Industries for their control systems to kick on pumps and motors and relays. And finally, we have MSA for gas detection. Everyone has chemical tanks in the water and wastewater market. They do as well, or you guys do as well, and as does industrial water wastewater. So we have, as you can see here, we have a chemical tank represented with a unique solution with that radar transmitter looking through the top of that plastic tank. And we just have a full suite of level solutions for chemical tanks and pits, as well as gas detection. One of the most challenging applications in a wastewater facility can be on their digesters. And again, we have a really good solution with our Vega Pulse 64 and capacitive solution as well. We can also help you with measuring your gas off of your digesters with our Fox Thermal instrument. We can also do that with a Yokogawa differential pressure transmitter. And again, we have gas detection in this environment as well. For flow, we have, for full pipe flow measurement, we've got Yokogawa for our inline full pipe flow measurement. And then we have Grayline for our clamp-on ultrasonic, as well as Doppler. For open channel, on the effluent part of the plant, we've got Vega for level, and we can also do pump control as well as alarms and alerts with our Vega controllers, as well as More Industries. Another unique solution we have with Yokogawa is their verification and calibration tool set, which there's a little slide down there at the bottom corner. If anyone's interested in that, we can certainly dive into that offline. And finally, some of the other key areas that we see quite a bit of is vibration and condition monitoring. That's huge in the water industry. A lot of you folks have pumps and motors that you're controlling, so we can help you there, and we can literally take it all the way back to where we're doing remote monitoring from one central location. All kinds of pressure solutions with Yokogawa. We have a custom programming group where we can do panels and custom SCADA projects. I'm not going to talk too much about SignalFire because we're about to do that. Wanted to also mention today, before we get started, that we have a full service group. Our guys are factory trained and certified in all of TechStar's instrumentation. We can do cal checks for your gas detection. As you can see here, flow surveys, wireless surveys, pretty much anything you need service-wise we can help you out with. And then finally, we have a full training group. We can teach Modbus classes, PLC programming classes, basic instrumentation is a big class that we do. But I also wanted to mention that we have a new state-of-the-art facility in our Houston office where we have full processing abilities that we can do custom training down there. And we can also bring our training solutions to your corporate office. Alternatively, in this time frame, we can do remote training online if you guys aren't able to get out and about. So if you're interested in that, or you have people that work with you that need some special training, hit us up, and we'd be glad to design a custom class for you. Having said that, I'm going to turn the controls over to our guest speaker. We have Sandro Esposito with SignalFire joining us today, and he is going to talk to you guys about all things telemetry in the water and wastewater industry. And Sandro, bear with me here as I stop sharing my screen, and then I'll kick it over to you.
You can hear me?
Yes.
Excellent.
You should be able to share your screen now, Sandro.
Yes, sir. And it's sharing right now. I just click the button. It's spinning. There you go. Okay. Well, good morning, everyone, and it's really an honor to be invited by TechStar to present to you, and hopefully you'll get something out of this session on telemetry. I'm located here in Houston, and I'll be presenting to you in some RF and cellular-based technologies that may be of use in your facilities. So real quickly, if I go over a company overview, SignalFire has been around for about 14 years. Our expertise is in low-powered electronics, battery-powered or externally powered, and using that low-power design expertise combined with telemetry is really a great offering, such that you can have an asset that will be monitored using as little as power as possible, while being reliable in terms of transmitting critical data of your operations back to your supervisory system. We have recently introduced or migrated from 900 megahertz to cellular-based technology. That one of the product I'll be covering, called the Ranger. And what truly makes us different is we are nimble in terms of implementing and deploying various technologies. We're quick to respond to customer demands. And one key important thing is that being sensor agnostic and also integration agnostic. So that means you probably have some transmitters right now. You probably have some measurements that you would like to have and bring back into your supervisory system without using wires. Well, with SignalFire, you can adapt our radios to a variety of inputs. And then you can be rest assured that you can also integrate into a variety of different type of host system using protocols like Modbus, or using milliamp signals, just analog, back into your system, or using Ethernet IP, or using cell phone-based technology. So our goal is to make it easy to measure a signal that you make a measurement from a transmitter, or command wirelessly a device that needs to be controlled, making it easy and reliable, and with security built in, to make it easy to go into your supervisory system. So the couple topics I'll be covering, I'm going to talk about protocols for cloud connectivity, something called MQTT that I'd like to elaborate a little bit more on, an emerging protocol from the past couple of years, but that's been around for quite some time now. I'll cover the Ranger. It's a unique form factor transmitter package that truly is plug and play, brings that measurement right at your fingertips, using cell-based technology. And I'll demonstrate this MQTT protocol, how it's simple yet effective in moving data from a device over to a monitoring software. I'll touch on what has been really our core platform for the past 14 years, 900 megahertz, but also how you can combine now 900 megahertz with cell-based technology to have best of both worlds. In some cases, this could be more cost-effective to combine both than using just an LTE-based device. Obviously, Q&A. I love questions, and I'll keep them for the end. But Jeff, as we go along, if you see anything that comes onto your chat box, please pause me, because I'd like to maybe address them as I go along if I'm on a particular topic or a slide, instead of keeping it for the end.
I will. Yeah, no problem.
So voice is okay?
Sounds good.
Okay, awesome. So first topic, some education on MQTT. MQTT is becoming one of the industry standard, we believe, in terms of a communication layer to bring data from an edge device, a host system, a transmitter, and whatnot, to bring that information into a supervisory software in the cloud, or it could be on-premise too. It does not need to be in the cloud. MQTT truly makes it efficient, fast to integrate, and it is power efficient from a sensor device, and you'll see why in a second. And this MQTT has been adopted by so many different companies now in terms of a means to get data into that system. So some of these that are listed might be familiar for you, like AutoSol, Ignition, VT SCADA, Ozai South Pi, a very popular data historian, Wonderware, the OPC Foundation, Signet, Aspen Tech, Integration Objects. I mean, and there's more. So the key takeaway here is that leading software companies are using MQTT as a means to quickly and easily and safely bring data into a supervisory software that is on the cloud or could be on premise. And a little like fun fact over here. I'm not too sure if you knew that Facebook Messenger actually uses MQTT to minimize the battery usage of your cell phone. And that the MQTT protocol was designed way back when for that purpose, to be extremely efficient in terms of moving data from a piece of hardware or sensor up into a software platform. So a little word on MQTT, or what it's a bit more nuts and bolts about it. At a high level, the MQTT protocol is a publish-subscribe type of messaging. So it allows a publisher to send a message to a given listener, or what's called a broker. So it sends a topic message that includes a topic, And then subscribers are all the different type of applications that are listening to, or are not listening but subscribing to that topic. So the part of the effectiveness of MQTT is the fact that when it publishes, it sends initially this birth message that includes all of the information of that publisher. By that I mean, what kind of range are we talking about? What are the units? All the tags available from that device are all published in a standardized format. And then the subscriber can subscribe to all these different tags. So there's no tag that needs to be programmed or set up. So from those of you that are familiar, like in setting up PLCs and DCS and control systems, the traditional way has been to, well, you set up the host system, the DCS, you set up the tags, and then you have to then link the tags to the IO that you're getting the data from. So all that pre-work is quite time consuming. MQTT eliminates all of that pre-work that needs to be done because the publisher sends all of that tagging information as part of a birth message. So the technology uses what's called a broker, or referred to it as the middleman. So the publisher, like in this case, I have here like on this table, there's a publisher. Here's the Ranger. So that's an example of a publisher. The Ranger publishes a variety of tags and topics. The broker is set up in the device. So the device has a setup that says, okay, publish to the following broker. And then the device only has information about the broker to push data to. The end device that's publishing has no knowledge of the receiver whatsoever. The only knowledge that the publisher has is whether or not there is a receiver that's ready to receive information that is available. But who is the receiver and so forth is inconsequential to this type of technology. So from your standpoint, you could host your own broker on your own cloud or on-premise, have your data broker that you control the security and everything, and then the publisher would publish to your broker. And then your application running in, like the ones I mentioned before, would be subscribing to that data or those topics. So that's kind of, in a nutshell, the MQTT platform. It was invented in 1999, and initially the purpose it was invented, or why it was invented, it was to overcome the challenges of pipelines that are in the middle of nowhere, communication to satellites that are very expensive. And so the two inventors of this standard came up with this strategy to minimize the number of bytes transmitted, and also to, like I mentioned before, like just send all at once all the information related to that device. And then now the satellite knows how to subscribe to that data, and only will receive the changes of those. Whatever changes will be sent. What doesn't change is not sent. So that was the premise of MQTT when it was invented in 1999. And now it's widely adopted in water, wastewater, industrial space like oil and gas, agriculture, chemical segments, just pretty much name it. MQTT is now a de facto standard, pretty much. Along the lines I mentioned why it was invented, to provide like a reliable data transmission using as little as bytes as possible. So MQTT uses way less bytes versus like an HTTP connection. If you're familiar with like HTTP type connection, the amount of data is like, maybe 100 to 1 in most cases. And there's a quality of service too. There is a quality of like, in terms of messages that are sent versus lost. MQTT independent survey shows that there's like 100% quality of service in terms of sending messages and being reliably received versus HTTP. So this brings me to the Ranger. So for all those reasons that I mentioned before on MQTT, this was one of the reasons, these are the reasons why we decided to implement MQTT as one of the foundation of the key pillar of the Ranger. So if you have the camera on, if you you can see the range over here. Jeff, can you see it correctly, or should I stop sharing so you can see it a bit better?
No, that's good. That's good, Sandro.
Okay. So the Ranger is a cellular-based device that transmits data using LTE Cat M1, and I'll touch a little bit on that. And it's fully integrated with the SignalFire cloud, or actually can be integrated with your cloud. It doesn't have to be the SignalFire cloud. That's a key aspect, is that you choose what's best for you. You have your own cloud application, your own MQTT type implementation. Well, you can program the Ranger to go to your SCADA system and not go to SignalFire's cloud-based application. The purpose of the device is to monitor and alarm on assets using off-the-shelf sensors. So you pick what's best for you in terms of measurement device, flow, pressure, temperature, and so forth. You pick what's best, and then the job of the Ranger is to provide power. If in many cases, it's able to provide power to loop power devices, to even command a valve or a pump using the relay output. So its purpose is to adapt to an existing signal in a form factor that is ready to be outdoors. So this device has a half-inch MPT connection and just will screw onto the asset that you have, or it could be remotely installed. And it's to make that measurement that is isolated, or running wires would be too costly. Well, we make it easy to go right to the cloud with this Ranger. So a lot of IOs here. I'll explain what they are. And again, one key aspect is this configurable broker. That the middleman could be ours, or it could be yours. So the broadcast technology for this Ranger is LTE M1, which is widely adopted, has been adopted actually globally by most cell carriers. So LTE M1 uses a different band than like the bands that your cell phone uses. So those bands have an even broader reach because it's a different frequency and lower bandwidth. So it has broader reach. So in some cases, you might say, well, I go with my phone in this area and I don't have coverage. I don't have good reception. That does not mean the Ranger will not have good reception. And that's because it's using a different band, lower bandwidth, and therefore lower bandwidth means like longer or greater distance from the existing power. The M1, Cat M1, is the advantage of this technology and why sensors like transmitters like this, we use Cat M1. It allows the Ranger to go to sleep while remaining connected with the tower, such that when there's a change of the measurement is made and ready to be pushed, it's instant. So that's the purpose of LTE Cat M1. If my cell phone, I go into airplane mode as an example, and then or turn it off and turn it back on, there would be a lot of it would maybe 20, 30 seconds plus, right, to get the tower to acknowledge my presence. With LTE Cat M1, this wakes up and right away can push directly to the tower, but also can receive from the tower. So your application that wants to send a command down to the relay and turn it on, or change a parameter, you can send it down as well to the Ranger. And that's the benefit of LTE M1. And the net impact is excellent battery life and getting your messages that you want on a good at the interval that you need. And it's secured, so the messaging is secure. We're using TLS. So TLS is the security we see all the time, but we use every single day when we do transactions online. So that's the latest and greatest internet security that is deployed, across the internet, right? Where the cloud platform that we're using was built on with Ignition by Inductive Automation. So if you do have Ignition by Inductive Automation, this will talk directly to it using Sparkplug-B format. If you have something else than Inductive Automation, as long as you have an MQTT capable software or host, the Ranger will be able to push to it as well. So that's kind of in a nutshell the Ranger, and I'll do a demo demonstration in a second. So here's the what it looks like inside. So if you looking at the camera, there's up to 3 analog input, 3 digital inputs, 1 relay output. It has a built-in GPS. So this antenna that you see here is the LTE antenna, as well as a GPS antenna. So you have the location of that measurement. Things that might be moving could be interesting to know. The measurement was made at, based on the location. From a power standpoint, battery is here. The battery provides power to your 4 to 20 milliamp transmitter. It reads digital inputs, also can measure like a flow meter, a pulsed output. Can be utilized from a flow meter to know the water usage today, the water usage yesterday, and so forth. So it is a pulse counter. It can also be powered externally or using solar. So we have a solar unit that can be plugged in right over here, or you can use your own DC power supply if you want to power with DC. So flexible in terms of inputs, flexible in terms of power, and also very versatile in terms of connecting to your cloud or someone else's cloud or your MQTT ready software. What we are coming out very soon is the Modbus. So right over here in the middle, we'll have Modbus, which means you would be able to connect this to a Modbus slave and then map the registers from that slave, and then the Ranger will make MQTT tags off of it and push that over LTE. What a key thing is like improvement, enhancements with firmware. Well, over the air, this can be upgraded. So we can push down to your Ranger over LTE connection a new firmware. So you don't have to physically go where the asset is to upgrade the firmware. And there is a USB port right there, micro USB port for if you want to do local configuration, bench configuration before it's connecting to the tower, or to reprogram the broker. Jeff, is there any questions? Because I cannot see the chat box. Anything?
So far, we do have a request for the PowerPoint presentation, and
okay.
So that's it so far.
Okay, certainly. So I could go over the cloud part overview, but instead I'm going to actually do a demo, and then I'm going to do two demonstrations. One will be I'll demonstrate the SignalFire Cloud, and then I'll demonstrate how you can redirect the Ranger to point to a different broker and show another application other than SignalFire's cloud application, how it's receiving the data. But overall, if you decide to go with the SignalFire Cloud application, it is computer mobile friendly. It's a web app. Allows you to monitor, track, measure all the measurements coming from the Ranger, which is attached to your transmitter. Configure alarms, receive SMS, text message, email, and the data is secured and hosted on Amazon Web Services for 3 years. So you know that you can have like reliable hosting of the data. It's using the proven and well-known Amazon Web Services. It's your data. You have your credentials to log into your account, which is segregated. It's, and then you can have access to your data and download it at your leisure. So let me just show you a couple. Let me just escape the screen. Let's go to. We'll click on. There is the cloud application. So here is the Ranger that I'm communicating to. Oops, something just fell on the floor. And if I go back to the home screen, here's the. I'm going to click on the home screen of the. I need to. Oh, for this thing. Okay, it's going to reload. There you go. Somehow the bandwidth is okay. Let me just open up another page. I'm not too sure why it's taking a while to refresh. SignalFire Cloud. So while this is loading, oh, this is unusually slow for my computer. Is very slow. Yeah, it's very, very slow. Apologize for that. I guess I'm going to have to call my service provider after this. So while this is loading, I'm going to pull the Ranger toolkit in the background. So here's the Ranger toolkit, which I'm going to connect to it using my micro USB cable. Okay, so the purpose of this this connection, I'm just going to show you like in a second. I'm going to click on Open. It's connecting to the Ranger, and the goal of this application, which is free, is to reprogram the broker that the Ranger is pushing to. So using this USB cable, you can see it's connected to like Verizon network, the cell phone or the signal strength, and then this MQTT status. You can reconfigure the I/O over here if you want to be connected to it, or all of this is configurable over the web app. And here's the MQTT tab. Right now it's directing to the SignalFire cloud. And if you wanted to redirect it to your cloud, you would just click on here, custom, type in your broker's information, and then go from there. So that's the purpose of the Ranger software, is to redirect the Ranger to a different broker. I'll demonstrate that in a second. So here's the home screen. Hopefully looks like my web connection is very slow, but the Ranger has these the GPS, so you know the location of the Ranger. This is mine is right over here. I'm going to click on this. So you can see the location of your measurements. You can view the measurements, and right from this web app, which will load also the same thing. If you load the web app on your phone, you'll be able to see the measurements right from your phone as well. So I'm going to put this down and then show you like now the tile view of the Ranger's measurements. So here's everything is trended. All the measurements are pushed to the cloud. You can pick the date range that you want. And you can, like I mentioned before, download all of the data as a CSV file. If you don't put it into Excel, or if you have your own broker, obviously things will go into your data historian. Like if I make, so that's the, this is the kind of interface that you get with the Ranger. All these tiles represent one of the inputs. Each tile is configurable for that given input in terms of scaling, range, entering units. So you can scale every single of these tiles according to your transmitter that you're measuring or you're getting data from. So the here you can see like a flow totalizer. Typical application in water, wastewater is like some flow meters. It counts all the pulses. Every pulse is accumulated at 2 kilohertz frequency, up to 2 kilohertz, and you set the units per pulse in order to get the total volume of that meter. For the analog, if you're putting this on a 4020 milliamp device, it provides power, or it could read the existing milliamps if it's externally powered. And here you put your ranges, the range related to that 4020 milliamp and the scaling. So it's very simple and easy, tile-based view that makes it simple to configure and monitor the information of that given transmitter. Any questions, Jeff, so far?
Not so far, no.
Okay. So over here, my Ranger is set to report like every, it's configured to report every 5 minutes, you see over here. So every 5 minutes, the Ranger will apply power to the milliamp, and then we'll push the values to the cloud. That's how it works. So you determine the frequency of update back to the cloud. I'm going to make a change here. I'm going to force it to report because I don't want to wait like the 5 minute interval. And then it's going to push to the cloud, and we'll see this value update. In terms of connectivity, there is also like we can offer it with a breakout box like this. And so that's a means to wire more sensors into a convenient junction box. Or you can wire inside the enclosure of the Ranger. This is optional. Should you start using like a lot of the IOs, it might get crowded over here. So that's why we have this convenient junction box with the U-bolts right here. Now let me configure the Ranger to go to a different broker. So you see the value got updated. So I'm gonna now switch to a different broker by clicking custom. My computer's running super slow. That's interesting. So I have a broker that signal-r.cloud. This is a broker that is not the SignalFire, it says SignalFire, but it's a different broker, okay? And then I'm gonna set this up to show that how easy it is to redirect to a different broker. Easy, but yet secure by supporting certificates. So here you can click on this button, and then you would load your TLS certificate that only you manage, you have control, you put into your application, you put in the Ranger, so that way only your application can see the Ranger. So it's very secure in terms of moving data using TLS. And in the background, what I have open, I have Ignition. So this is could be another SCADA system that uses MQTT. I have Ignition over here. I'm gonna just click apply those settings, and then it's gonna reset the MQTT broker. It's gonna attempt to connect to that broker. And then when it's connected to the broker, we'll see those values over here coming live in real time. So that all of these values, once the broker is set and live in the cloud, we'll see these values come in. And that's how you set the MQTT broker with the Ranger.
Hey, Sandro, we
Yes.
do have a few questions.
Yes.
Okay, the first question is, how secure is the SignalFire private cloud in layman's terms?
Well, it's secure in this. Well, first of all, from the cloud, our cloud application has username and password, so that you only have access to. So you create an account that you own, and SignalFire manages the account. So from you logging into your account, it's secure. It's only, you can only see your devices. So that's part one. Part two, in terms of connectivity, like I mentioned, using the TLS certificate platform is what we use every single day to do transactions, and what it is an internet standard. It's TLS. So the fact that we support TLS makes it also secure to move data from A to B into our cloud application or into yours.
Okay, I've got a couple more questions. Do you want to wait till the end or just keep going?
Yeah, I can keep going. I'll finish this and then we can do all the questions. So here you see now that all the data came live. Go ahead. You there?
Yeah, go ahead, and we'll do the questions at the end.
Okay. So you can see before everything was red, and now everything is live. So right now the Ranger is publishing to a different broker, and Ignition is this Ignition application, which is not the SignalFire Cloud, is now receiving the data from the Ranger. So I've redirected the Ranger from the SignalFire Cloud. I've redirected it to some other cloud-related instance or under cloud application. So that was just to demonstrate this kind of like publish, subscribe. The Ranger was publishing to a broker, which was associated with the SignalFire Cloud. Now it's publishing to a different broker associated with this application that you're seeing on the screen. So I'm going to go back to the PowerPoint now, just to for the next couple minutes before we do all the rest of the questions. So some applications, so we said the Ranger is quite hot because there's so many applications that are suitable for the Ranger that can help you out. Like this is a pipeline water pressure application. There's a transmitter underneath that bunker. And so it's measuring the pipeline pressure, pushing it to the cloud. We've got some on like GC, gas chromatographs, water table, chemical tanks. There's some application that, you know, might be of interest that we're also like, we have it installed, or we have right now like a lot of requests for these applications, like lift stations, lift grinders, monitoring diesel generators, canal levels, tank levels, a worker monitor regulator gas, gas reducing stations, irrigation pump control, water irrigation meters. So the Ranger is that simple, effective, secure way of putting a measurement in, you know, at your fingertips without adding wires and without any programming skills necessary. So if I, oh, this was not my slide. I guess my slides are hidden. Yep. So now I'm going to switch gears to essentially to RF. So switching gears to RF technology. So right now I covered like LTE-M1, and which is something that you could probably make use of today. You probably have some applications in mind right away that, you know, you have a measurement here or a pump you want to monitor there, and it's plug and play. In some cases, you may need to use RF technology. So SignalFire has been using 900 megahertz for now 14 years. The advantage of 900 versus 2.4 or 5 is that it's a longer distance, better penetration and through obstacles, so more reliable than 2.4 and 5. So that's why we use 900 megahertz. The RF platform of SignalFire, so I have one sitting right over here. So this is one of our popular nodes. Over here you have the radio, the battery. This can be solar powered. I have a transmitter attached to it. So this will provide power to the transmitter if it needs power. And then it pushes 900 megahertz back to a gateway, a 900 megahertz gateway that we offer. So this platform is also agnostic. Various inputs, capability, Modbus, hard 1 to 5 volt thermocouple. There's a variety of capability with this radio. We do also have like some built-in sensor with the radio. Like this is a pressure transmitter. So it's a wireless pressure transmitter using 900 megahertz. We also offer like some I/O, some wireless I/O using 900 megahertz, where you can wire up signals and push it back to a gateway. The platform looks like, or the technology is mesh capable platform, so where a node can transmit to another node and then reach the gateway. So all of these links are 900 megahertz. The node wakes up, makes the measurement, pushes it to the gateway. Or the gateway can push to a node that, in the case of controlling a relay output or controlling a 4020 milliamp as an example. So in some application, you may have several devices within a couple square miles that it would be cost efficient to aggregate those to one access point and hook that up to your PLC or control panel using Modbus signal. So the output of our gateway that you see here, so this gateway is Modbus output, or could be also 4020 milliamp output as well. Applications that could be a benefit, like I say, is collecting multiple devices within a 900 megahertz range, which could cover like several square miles, and that could be of a cost-effective implementation. You can combine. What's interesting is like you can combine 900 megahertz now with cellular with SignalFire. So these 900 megahertz link back to the gateway very soon. We're about 2 months away from releasing this capability with Modbus on the Ranger. So using the Modbus output of our gateway, we can read those measurements that are coming in by using 900 megahertz. So therefore, one cell connection, one data plan to manage, and that could be a very cost-effective solution in combining 900 megahertz measurements with the Ranger as a means to bring it to the cloud with MQTT protocol. That's what I had like for everyone in terms of going over like telemetry with cellular and telemetry with RF 900 megahertz. You can test drive the Ranger today by visiting our website. You can experiment the web application. Just click and test it out yourself. It's a live instance of our cloud application. And on that note, I'll answer the rest of the questions that you have, Jeff.
Okay, here we go. How does Ranger compare to Telelog products and monitoring?
My understanding of a Telelog, again, I won't pretend I'm an expert of a Telelog device, but Telelog, my understanding, it's a data collector. It does local data collection and pushes over to the cloud. Ranger can do that data collection in the cloud and do some at the device level. The Ranger uses MQTT, which might be simpler to integrate into your your existing application, more versatile from an input standpoint, and that would be the kind of key main differentiator over Telog. But again, I won't pretend that I'm an expert at the Telog product.
Understood. Next question is, does cloud connection require connection to the internet? Is it possible to communicate at a local secure level only without connection to internet?
Well, you could do that with RF, so an on-premise connectivity where you're using 900 megahertz. If you're using cell connection, then you do need a connection to the internet, because the LTE connection ultimately connects using points to an MQTT broker. So there is a connection to the internet. With SIM cards, it is possible to turn on a SIM card a VPN. While many experts believe that the VPN is not necessary with using TLS security in this MQTT platform, but you could just do a VPN connection with your cell provider on the SIM card that you would put into the Ranger. But a connection to the internet to go to the cloud is necessary, and on-premise monitoring is possible using 900 megahertz.
Okay. Before we get off here, can we talk briefly about the SignalFire capabilities at the plant level for wireless monitoring?
At the plant level, certainly using HART is one of many, but at the plant level, putting a Ranger on top of a tank to get the level of a tank, or to monitor the start-stop of a pump, to measure chlorine levels using an ORB sensor. So at the plant level, pipeline pressure, water pressure, pump pressure, all that is possible at the plant level using our 900 megahertz platform connected back to our gateway, like this one here. And then the output goes into your existing SCADA system that is on premise using Modbus TCP or Modbus serial, and also Ethernet IP. So at the plant level, whether it's a RTD thermocouple 4020 milliamp 1 to 5 volts, Modbus, I think I mentioned, SDI 12, we also support SDI 12, popular in water, wastewater, irrigation market, that protocol, HART. So a variety of measurements that you may need, and also control. We can control relay outputs with our wireless I/O. So at the plant level, you can minimize the use of wires or things that are isolated using 900 megahertz with SignalFire. Is that where you were going, Jeff? Or,
Yes, and I've got a couple more questions here. This is good. So we have municipalities that have to meet Homeland Security requirements in terms of their SCADA and so forth. How does the Ranger fit into that conversation?
Well, the Ranger uses TLS, so it would be a matter of Homeland Security approving the use of TLS, which I would think they do, because when you go on the various U.S. related sites, such as the IRS, the TLS is the method to secure the transaction going from a computer to computer. So without looking too much into it, that would be my answer, is, because the TLS is the internet layer, is a security for the internet layer.
Okay. And I think that is the last question that we had for today.
Um, and one other point on security and homeland security is this concept of like the Ranger. There's not like an IP address that you can point to on the Ranger. That concept does not exist. And so the only connection you have is with a broker, and you can read from the broker. So this is why MQTT is quite secure, because there's no direct connection from the subscriber and the publisher. They don't talk directly to each other. There's a middleman in between with that the publisher publishes to. And that supports also TLS security as well. So
that's good to know. Do we by any chance have a white paper discussing some of that?
Yeah, well, the co-inventor of the MQTT protocol, his name is Arlen Nipper. People can like maybe search his name, Arlen Nipper. He's the one of the two founders of the MQTT protocol, and talks a lot about security. Several companies in the upstream market, such as Chevron and ConocoPhillips and others, they've adopted MQTT, and they have probably the same security concerns from some malicious attack that could make use of the data, or if you're doing some controls to make something turn on or off. And these companies have adopted MQTT as part of their like telemetry backbone.
Okay, well, thank you very much, Sandro. If anyone out there has any more questions, feel free to reach out to TechStar, and my email address is jreiser@techstar.com, and I will get those questions answered or get those over to Sandro. And so, having said that, we appreciate everyone's time today, and thank you, Sandro, for being our special guest. You did a great job.
Thank you, sir. My pleasure. Have a good day.
Thank you, everyone.